Welcome to the tutorial on stoichiometry. Stoichiometry looks like a complicated word, but really stoichiometry is just the idea of identifying the amounts of products and reactants from a balanced equation using mole-to-mole ratios. We're just going to use a balanced equation to be able to figure out how much of the reactants can create products, or how much of a reactant is needed to react with another reactant. And the key here in the middle is this mole-to-mole ratio from a balanced equation. With stoichiometry, we will typically start with grams, and we will convert that grams into moles by dividing by the molar mass of the component. And then once we're in moles, we can change from moles of one component to the moles of any other component in a balanced equation using that mole-to-mole ratio. Once we have moles, we can go all sorts of places. Back to grams by multiplying by the new component's molar mass, or we can divide by liters to give ourselves molarity if we're dealing with a solution, or we can divide by molarity if we're already given a concentration and figure out volume. So we have lots of different avenues in our stoichiometry problem solving. Let's do an example of the basic grams and grams conversion and identifying a limiting reactant. Here in this experiment, we are given 6 grams of magnesium to react with 3 grams of oxygen gas. Let's identify the product amount and the reactant amount left over after the reaction is completed. So first we have to start with a balanced equation. Here we're going to be reacting with magnesium with oxygen gas. So our reactants are magnesium solid with oxygen gas. And our product in this case is going to be magnesium oxide. So there's our 2 reactants and our 1 product. Now we need to balance this. So we quickly surmise that we don't have enough oxygens on the right side, 2 oxygens on the left, 1 oxygen on the right, so we're going to put a coefficient of 2 in front of the magnesium oxide. And now we need to balance the magnesium, so we're going to put a coefficient of 2 in front of the magnesium solid. Now we have a balanced equation, and now we're ready to do our stoichiometry. Alright, so let's kind of have a table here so we can realize what we're starting with. We're starting with 6 grams of magnesium and 3 grams of oxygen, and we're going to start with no product. We want to know how much product can be produced, and in order to determine that, we need to figure out which of these reactants is going to limit our reaction, or which of these reactants is going to run out first. And in order to do that, we have to do some calculations. So let's flip back to the previous slide, and let's see. We're given mass of 2 different components, so we need to figure out which of those can produce the fewest amount of product. That's how we do a limiting reactant problem. Alright, so we're going to do 2 calculations here. We're going to take our 6 grams of magnesium, and we're going to convert that to product, and simultaneously we're going to take our 3 grams of oxygen and convert that to product and see which is less. That's going to tell us what our limiting reactant is. So we have to do some mole-to-mole conversions. First step is to figure out how many moles of magnesium that is. We look on our periodic table. Magnesium's molar mass is 24.31. So we have that many moles of magnesium. And now what we're going to do is we're going to string together a mole-to-mole ratio to go to product. So 2 to 2, got 2 moles to 2 moles. Alright, so 2 moles of our product is produced for every 2 moles of magnesium reacted. Alright, so let's cancel off all of these, and we are left with the mass, or the moles of product produced. We're going to do the same thing with our oxygen. 1 mole of O2. Oxygen weighs 16 basically, but O2 is going to be 32. Now our mole-to-mole ratio is 1 to 2. We're going to get 2 moles of product for every 1 mole of O2 react. And there we have our stoichiometry calculations to figure out the limiting reactant. So let's just plug these into our calculator really quickly. Alright, so we plug those into our calculator. 6 divided by 24.31 times 2 divided by 2, that's going to give us 0.247 moles of MgO as a theoretical yield if magnesium is the limiting reactant. And then for oxygen, 3 divided by 32 times 2 over 1 is going to give us 0.1875 moles of product as a theoretical yield if that's the limiting reactant. So now we compare these two. We say which one is lower. Obviously, this amount is lower, and so oxygen is our limiting reactant for this reaction because it produces a smaller amount of product. Alright, so now we can come back up here and say, as the reaction proceeds, what's going to happen is all this oxygen is going to get used up. Right, that's the limiting reactant, so this is what's going to get used up. And now we need to figure out when that 3 grams gets used up, how much magnesium oxide can it make? Well, we found here the theoretical yield in moles. Now what we want to do is find that in grams. So we have to convert the moles of magnesium oxide to grams by multiplying by the molar mass of magnesium oxide. So we quickly take a look at the periodic table again. The magnesium weighs 24.31 plus 1 oxygen is 16. So we find that that is a mass of 40.31 grams per 1 mole. And so when we multiply that out, we find that we get 7.56 grams of magnesium oxide is the theoretical yield. So now what we need to realize is that this magnesium originally was 6 grams. We're not going to use all that up. Oxygen is a limiting reactant, so there's going to be some extra magnesium left over. So we want to figure out how much of this magnesium is needed to make this reaction go. So I need a little more writing space. So in order to do that, I'm going to take my limiting reactant, 3 grams, and I'm going to see how much magnesium is needed to react with that amount of oxygen. So we got 3 grams of oxygen. We convert that to moles of oxygen, and now we're going to use the mole-to-mole ratio, and our balanced equation showed us that 2 moles of magnesium will react with 1 mole of oxygen. And then we go right into and change this back to grams of magnesium by multiplying by the molar mass of magnesium, and that will give us the amount of magnesium that is needed to react with that limiting reactant. Plug that into our calculator, and we get 4.56 grams of magnesium solid is needed to react with our limiting reactant. Alright, so we're going to have some leftovers here. The leftovers, remember we started with 6 grams, but we only used 4.56. So we're going to have 1.44 grams of magnesium left over. We're going to have 0 oxygen left over because that's our limiting reactant. And so at the very end of this reaction, we have this amount of leftover reactant and this amount of product that gets produced. Should see these numbers should match up, and we see that the 4.56 plus the 3.00 using the conservation of mass gives us the 7.56 grams of product. That's another way we could have figured out that 4.56, but I showed you a way using stoichiometry. That's not the only route.